Alright, let's clear something up right off the bat. This series is intended to be comprehensive. That means it covers everything I know from start to finish. It's a complete offloading of every thought there is inside my brain right now. Most people aren't so ambitious because it turns out that sharing everything you've ever learned takes a long-ass time. But whatever, I'm still young. It's not like I've got any bigger plans for the rest of my life. I can do this series for years if I have to. So when I say I'll share everything I know, I mean everything. With that in mind, let's start at square one here with counting math, also known as arithmetic, the operations of addition, subtraction, multiplication, and division. I know, it's probably insulting for me to suggest that you don't know how to add and subtract, but hear me out here. There are a few tricks I came up with for doing mental math that make arithmetic a lot easier. Tricks that I wish somebody had told me about years ago. Would have saved some embarrassing letters between my teachers and parents, that's for damn sure. Also, this might come as a shock, but adults tend to be bad at arithmetic exactly because it's simple. If you fail at something difficult, at least you can save face by saying that you were up against a tough challenge. But if you fail at something easy, there is no way for you to keep your dignity. The prospect of messing up a simple addition or subtraction problem is so embarrassing that to avoid humiliation, grown adults will chicken out from doing second-grade math problems by hiding behind the fig leaf of calculators and cell phone apps. Of course, the chances of messing up arithmetic by making a calculator error are about as good as messing it up with a mental math error, but at least then you have something to blame other than yourself. So whenever a group of people have to work out a restaurant tip, out come the cell phones, tapping away. Apparently, it takes a multi-billion-dollar industry 60 years to develop electronics to the state of the art where they can handle the complex and difficult task of dividing a number by 5. Keep in mind that these guys who are struggling to split a bill are the same people who run your civilization's military, economy, and government. Yeah, have fun sleeping tonight while you're thinking about that. That's why we need to start from scratch here. Do you want to just get by at math, only to forget it all so you can wimp out and hide behind a phone for the rest of your life? Or do you want to be awesome at math and do it quickly and confidently to the envy and astonishment of all your friends? It's like this. Of course you have the ability to learn addition and subtraction, right? But once you get those under your belt, there's no real reason why you can't learn the rest of arithmetic. And if you can learn all of arithmetic, well, why not the next branch of mathematics? And if you can learn a couple of branches of mathematics, why not all of mathematics? If all of mathematics, why not all of science? If all of science, why not the entire sphere of human knowledge? Why not learn everything that can be learned so that you never have to feel insecure about your own ignorance again? If there is a staircase to the stars, then the first step is right here. Now do you want to learn arithmetic? I can't hear you. That's what the hell I thought. Let's get started. This is Animus Anthem. Okay, let's get started. Let's say somebody asks you to add the numbers 15 and 18. The way they teach you how to do that in school is to write the two numbers down, one on top of the other, then add up the digits in the ones place first. You get 13, so you have to drop the 3 down, then carry the 1 over to the tens place and add the tens together. While that method will eventually get you the right answer, it's not really designed for being done without pencil and paper. Don't believe me? Try adding the numbers 27 and 58 in your head. No cheating. You can't write anything down or look at a computer screen. Just use your imagination. Yeah, not so easy, is it? It gets harder when the person talking to you can't be put on pause like this video. They're just in the room, staring at you, and constantly talking and breaking your concentration and judging you, making you feel stupid when you fumble around for the right number. Now, when I used to add stuff in my head this way, even if I got past the issues with concentration and somehow managed to stumble upon the right answer, I usually ended up doing the calculation in my head a few extra times to make sure the answer was right before saying anything stupid and embarrassing myself. This is normal. Everybody does that. That's because when you try to do these sums in your head, what's going on in your brain looks something like this. Okay, 27 and 58. Add the 7 and 8 together to get 15, drop the 5 down, carry the 1 over to... what was in the tens place again? Kind of forgot. Okay, start over. 27 and 58, right? Okay, so there's a 2 and a 5 in the tens place, so they add to make a 7. So then we carry over, what was it we're carrying over again? A 1, right? Okay, so 7 and 1 makes 8, so the answer is 80... what was in the ones place again? Okay, start over again. Okay, one last try. 7th time's the charm, right? Yeah, once you see what's going on inside your own head, it's not hard to see why this method is so difficult to perform mentally. You have to perform operations on one digit while remembering the numbers in another digit at the same time. The human brain wasn't meant for that kind of abuse. Let me show you how I do it. 27 and 58 are hard to add, right? But what if I asked you to add 25 and 60? Say it with me now. 85. That one's not so bad because there's no carrying involved. But here's the thing. 27 plus 58 is the same problem as 25 plus 60. All we did was split a 2 off from 27 and group it with 58 to make 60. That's what I do when I need to do addition in my head. I'll see how much I have to steal from one number to round the other number off to the nearest multiple of 10. That way I never have to do any carrying. I picture this in my head with one number cracking apart like an egg, with a little piece of it joining the other number. So I call this number cracking. Look at that beautiful animation go. Yeah! I could have also gone the other way around, too. Instead of stealing a 2 from 27, I could have stolen a 3 from 58. Then the problem would have become 30 plus 55, and it would have led to the same answer, 85. You can choose whichever works for you, but I usually find it easiest to borrow the smallest amount possible, so I went with the first option. That's not quite all there is to it, though. Without paper, I still struggle with trying to picture the numbers in my head while I'm doing operations on them. So here I take advantage of my auditory memory, my hearing memory. What were the last 2 words of that last sentence? Hearing memory, right? Okay, but how do you know that? Because you can remember the sound of me saying those words. It turns out that your brain holds on to the last few sounds it heard for a little while. It doesn't last forever, and the old words keep getting replaced by new ones, but you can still take advantage of this as a sort of temporary memory space. It's like this little scrap of paper where you can keep things written down for a few seconds before they disappear. So if I have to add 27 and 58, I'll just say 2758, either out loud or in my head. Even if the picture of the numbers fades from my memory, the sound of the numbers will still hang around for a few seconds. Saying them out loud puts them into my auditory memory, where I can hold on to them for the second or so that it takes to move the 2 around. Once I got my new numbers, I'll say 2560, either out loud or in my head. By this point, I've completely forgotten what the original 2 numbers were, but hell, who cares? It's the same problem. For the last step, once I got the words 2560 in my memory, I can add them together to get my final answer, 85. So the whole thing together looks and sounds like this. 2758 is 2560 is 85. Notice how I didn't say the words 27 plus 58. That's because my auditory memory is really short. I can only store things there for a second or two before I forget them. So it's important to express the ideas as quickly and concisely as possible so I don't run out of time. I don't need to say the word plus because I know that I'm trying to add 2 things together. So I drop any words not necessary to the operation when I say them to myself. You can pause the video and try an example for yourself. Try 38 and 53. I'll get you started here. 38 and 53. Get it yet? I did it by saying this to myself. 3853 is 4051 is 91. If you got it in time without having to pause the video, congratulations! Now do mental addition as fast as I can. I have nothing left to teach you. You have mastered the technique. The web series is over. You can go home and watch TV for the rest of your life. Hey, get your ass back here. I was just kidding. What, you think the offloading of my whole entire brain amounts to one trick about addition? Individual, please. I gotta make a career out of this shtick, remember? If you didn't get the answer before I did, don't stress out over it. I've had a long time to practice these. The good news is you can practice these whenever and wherever you feel like. All you have to do is randomly choose 2 two-digit numbers in your head and add. It makes for a nice distraction whenever you find yourself in situations where you'd rather be thinking about something else. I should probably point out here that there's no reason you can't use this strategy for bigger numbers. If somebody asks me to add 139 to 246, I do it like this. 139, 246 is 140, 245 is 185, 200 is 385. These take a bit more practice. There are a few things to note here. Notice how I didn't say the words 139 since my auditory memory is way too damn short for all those big long words. I just called it 139. It's even more important than usual to keep the word short here since the numbers we're dealing with take longer to say and will cost more of your memory to hold on to. Also notice that when I did the second step there, 140, 245 is 185, 200, I didn't try to round 140 up to 200. That would have involved borrowing 60 from 245, which is a little tricky. I could have done it that way to get 200, 185, but I find it easier to just dump all of the tens and ones places together to get 185, 200. It would have also been just as easy to group the tens and ones places together with the second number instead to get 100, 285. There's no standard procedure here, you just group the numbers together by whatever involves the least amount of work for you. That's all intelligence is, really, inventive laziness. You can add even bigger numbers the same way, just as long as you find a fast way of saying them to yourself. It starts to get hard with 4-digit numbers because they take so long to say that you start to run out of memory before you can finish the calculation. It's possible to do this with 5 and 6-digit numbers too, but if you practice those, be sure to keep it to yourself. No one likes a smartass. Okay, so we saw how with addition we can completely avoid having to carry numbers by cracking and rearranging. The question is, can we use a similar shortcut with subtraction to avoid having to borrow numbers? I'll do you one better. We can get away with never having to do subtraction at all. I am about to unveil the biggest cover-up of the millennium, so get ready to get your mind blown straight out your ears. Ready? Here it is. Subtraction doesn't exist. There is no such thing as subtraction. It's a conspiracy invented by elementary school math teachers to pad the curriculum and keep the students busy. You never really subtract a number, you're just adding a negative. Now maybe that sounds like splitting hairs, so let me show you what I mean. What happens if somebody asks you to do 53 minus 18? The textbook way of solving this problem is to write the numbers down one on top of the other, then do 3 minus 8, then realize you can't because 3 is too small, so then you have to borrow a 1 from the tens place to do 13 minus 8 to get 5, yada yada yada. Using this method, subtraction is just as hard to do in your head as addition, and for the same reason. You can't operate on the ones place in your imagination while trying to remember what's going on in the tens place at the same time. So here's what I do. We're trying to find 53 minus 18, right? In other words, the answer we're looking for is 18 smaller than 53. Another way to write that is, our answer plus 18 equals 53. See what I did there? It's no longer a question of subtraction. Instead, now it's one of addition. So now the question is, what do you add to 18 to make it equal 53? You can start by adding 2 to round it up to the nearest multiple of 10, making it 20. Then you need to add another 30 to bring the total up to 50. Finally, you tack on an extra 3 to bring the total up to 53. So your answer is 2 plus 30 plus 3, or 35. Ta-da! No subtraction involved, just addition. Now, that did involve a lot of little steps, so you can imagine that it would be kind of tricky to remember everything in your head. But here we can use auditory memory to help out just like we did with addition. I would say out loud the numbers that I'm trying to add together. So, while I'm picturing the number 18 getting bigger and bigger until it gets to 53, I'm saying the words 2, 32, 35. Try an example yourself. Try 85 minus 37. Ready? I did it as 3, 43, 48. It can be a little bit tricky trying to remember what number you're trying to reach if you take a long time to say the words, so like before with addition, I find that this actually gets easier to do the faster you can say it. Also, like with addition, this takes a little practice, so don't get frustrated if you don't get it right away. Let's try a slightly different example. What about 37 minus 14? Well, I could do it like before, add 6 to 14 to get 20, then add 10 to get 30, then add 7 to get 37, but that's annoying because then I have to say 6, 16, and then I get stuck because I have to think for a second about what 16 and 7 is. I hate having to carry numbers, so I'd have to crack the 7 into a 4 and a 3 in order to add everything together. That's a problem because anything that slows me down will screw me up. By the time I've done that extra step, I have totally forgotten what the number I'm trying to reach is. There's an easier way to do this problem. Instead of adding 6 to 14 to round it up to the nearest multiple of 10, we can instead just add 3 to it, so that the ones place of our running total agrees with the ones place of the number we're trying to reach. So out loud, all I have to say is 323. That's a lot simpler since I don't have to worry about that extra step of number cracking. What made this problem special? How come for the first two problems we started off by rounding up to the nearest multiple of 10, but with that last problem we started off by only rounding up to 7? The secret is in the ones places. If the ones place of the first number is smaller than the ones place of the second number, that's a situation where you would normally have to borrow numbers if you tried to solve it the way they taught you in school. In those cases, the cases where you'd have to do borrowing, it's easier to round up to multiples of 10 first. In the other situation, if the ones place of the first number is bigger than the ones place of the second number, we wouldn't have to do any borrowing. In cases like this, it's easier to round up by just enough for the ones places to agree. So the rule I use is, if you're doing subtraction where borrowing would be necessary, you start by rounding up to the nearest multiple of 10. Otherwise, if borrowing would not be necessary, you start by only adding enough to make the ones places agree. You don't really have to follow this rule. The only thing that matters here is that you realize that subtraction is just reverse addition, so adding the pieces together in any order will get you the right answer. But if you do follow this rule, it will guarantee that you never have to carry or borrow numbers. Just something to think about. Okay, so to summarize, with addition, you don't have to carry numbers. Instead, you can just crack numbers by breaking them apart and grouping them together however's easiest. And with subtraction, you can just do little pieces of addition instead. The pieces of numbers that you add up can be added in any order, but I find it easier to round up to the nearest multiple of 10 if borrowing's involved. Otherwise, I just start by rounding up just enough so that the ones places agree. With both addition and subtraction, you can remember the numbers easier if you rely on both visual and auditory memory by picturing the operations in your head while saying the numbers out loud. Alright, so that's addition and subtraction finished. Done and dusted. I am never going to talk about them again. So we've covered all of first grade math in, 15 minutes? Next episode I'm going to talk about something that kicked my ass all throughout second grade. And third. And fourth. And most of fifth. Stay tuned!